Hi everyone. Since there is a test next week on Tuesday, and the last topic is this week's work, which is binomial distributions, I thought I would do a little quick video to go over binomial distributions since it's important. I will also update the notes since the notes talk about using Excel, but it uses the formula for the old Excel 2007. It still works. No worries, it still works. But I thought I would update you on the new Excel 2012 and beyond. So this is what you do. So we're going to do it all three ways. So here's an example of a binomial distribution. So binomial distributions, first of all, are distributions where you have only two choices. The two choices are success or failure, or if you want, true or false. That's why it's called a binomial distribution. There's only two answers, yes or no, true or false, success or failure. The second thing that a binomial distribution needs is that all the trials, every time you do this experiment or this game or whatever you want to call it, it has to be independent, which means when you play the game this time or you do the experiment this time, it will not affect the experiment next time. So that's what it means to be independent. Thirdly, you need to make sure that all of the probabilities will be the same every time you do the experiment, all right? And that you have and that you know exactly the number of times you do the experiment. So if that's the case, then it's a binomial experiment or binomial distribution, and you can use the binomial formula, which is, let's do that, b x equals, it's going to be n choose x times p to the power of x times 1 minus p, or q if you want, failure, to the n minus x. Okay, so if p is the probability of success, then 1 minus p is the probability of failure. So this formula is the binomial formula, and it computes individual probabilities. Now, let's do this example. 60% of people who purchase sports cars are men. If 10 sports car owners are randomly selected, A says, find the probability that exactly 7 are men. So we're looking for the probability that x equals exactly 7, no more, no less. This will be 10, which is the number of times that you do the experiment, 10 sports car owners. You randomly select that from there. And you want 7 to be successful in this experiment, and to be successful means that you guess that there will be 7 men. Times, the probability of success will be 0.6 to the power of 7. That's the x. Times 1 minus p, or 1 minus 0.6, which is 0.4, to the power of 10 minus 7. 10 minus 7 is 3. So we can use our calculator. So I'll bring the calculator up here. And we can use the calculator to compute all of this. 10 choose 7. 10, second function, choose 7 equals. That's 120. I won't write it down. I'll just store it. Store 1. The next one is 0.6 to the power 7. 0.6 exponent 7 equals 0.0279936. Store 2. The last one is 0.4 exponent 3. And that's 0.064. Store 3. I'm going to multiply them all together. Recall 1 times recall 2 times recall 3. This is equal to 0.21499. So in that case, we're going to round that to 0.215. Okay, or if you want, 21.5% chance. So there's a 21.5% chance that if you looked at 10 sports car owners, exactly 7 of them will be men. And that's how you do that. We can also do it using the table. The table looks like this. The table looks like this. This is the table that you get in your textbook, and they are individual binomial distribution probabilities, which means they give you exactly what you would put in if you put x in for the formula. The other type of table is called a cumulative table, which is not in your textbook, but it's sometimes useful, but we won't need it in our case. The binomial tables that are cumulative look like this. So here's x equals 0 up to 10. The probability is along the top, just like before, but you'll notice that the last row is always going to be 1. That means that they accumulate, or they all add up to 100% at the very end, which is what you would expect, right? So for example, if you looked up 3 successes at 60%, it would be 0.0548, but that's not exactly 3. That's x equals 0 plus x equals 1 plus x equals 2 plus x equals 3. So it adds up. They're cumulative. Whereas the table that you get are all individual. If you wanted more than 1, you would have to add them all up. And you know it's not a cumulative if you look at the last row and it's not equal to 1. So let's use the formula of the table in our textbook, which is the table you will get. N equals 10. That's the number of trials. Exactly 7 successes, or seven of them will be men. 60% chance it's there. So if, by the way, if it's not in the table, you're gonna have to compute it either by Excel or by the formula. So 60%, 7, and you look, and if you look here, it's 0.215 right there, which is exactly as we compute it. Okay, so that's the other way of doing it. Let's go back to Excel. So we can also do it the third way. The third way is to use the built-in function. So we type equals binom, and you see things come up. The first one is binom.dist. The second one is binom.dist.range. And if you look down, it's binom.dist, which is for the old Excel, but it still works. Okay, so binom, we're going to use the new Excel. So binom, you press a dot, D-I-S-T, all right? You open a bracket and it tells you what to put in there. The first one is number underscore s, which means the number of successes, right? The number of successes that we want in this case is 7, comma, the number of trials. How many times do I want to play this game, or how many times do I want to do this experiment? 10, comma, probability underscore s. The probability of success is 0.6, comma. The last one is cumulative or not cumulative, true or false. So you either type true or you type false, or you can type 0 or you can type 1, doesn't matter. True means that it's cumulative, which means it adds them all up, just like the table I showed you. We don't want them to add up, we just want the single probability, so we say 0, or you can also say false. Close the bracket, and you see it's 0.215, which is exactly as you would expect. Okay, so let's do another one. So the second question is find the probability that at least 7 are men. So at least 7 means the binomial probability of, let's get that out of the way, of bx greater than equal to 7. At least means the minimum there are 7. So this is equal to the probability that x equals 7, or the probability that x equals 8, or the probability that x equals 9, or the probability that x equals 10. At least means from 7 up to the very end, which is 10. So 7 or 8 or 9 or 10. So if we do this by the formula, which I'm not going to do, you put in for x equals 7, which we've computed. Then you need to calculate for x equals 8, just like we did before, x equals 9, and also x equals 10. You compute all of those and you add them all up. You can also look up the table, which looks like this. So the table looks like this. Here again, we're using n equals 10, and we want, and p equals 60, sorry. We want 7, which is 0.215. We want 8, which is 0.121. We want 9, which is 0.040, and we want 10, which is 0.006. So for B, at least 7 means 7 or 8 or 9 or 10. So we take our calculator and we add them all up. So 7 is 0.215. Let me move that over there. 0.215 plus 0.121 plus 0.040 plus 0.006. And the answer is 0.382. All right. So let's go back over here. So this will be equal to 0.382 or 38.2%. Okay, and you can also get the same result if you compute all of these using the formula, right? And you add them. Let me demonstrate the cumulative table as well in case that that ever comes up. The cumulative table looks like this. So what we do is we go to 0.60 right there, right, for n equals 10. And I see that that's the second row, right? So I want 7, 8, 9, and 10, which means if I look at 10, that's 1. That's 100%. But that includes all the numbers from 0 all the way up to and including 10. I don't want that. I just want 7, 8, 9, and 10. So what I do is I subtract from 1 all of the numbers from 0 all the way up to 6. So if I subtract the cumulative probabilities up to 6, I'm left with just 7, 8, 9, 10. So I take 1 and I subtract 0.6177 equals 0.382, which is exactly as we would have done with this one by adding them all up. We can also use Excel. So if you use Excel, we type equals binom dot, and again we have a whole bunch of things that pop up. In this case, you can do binomial.dis and do all 4 of them and add them up, or it's easier to choose the second one, which is .dist dot range. Range means that you have a range of numbers that you want to add up. So the number of trials, open the bracket, is 10. The probability of success, right, which is 0.6, comma. The first range starts from 7, comma, and goes up to the second range, which the higher range, which is 10. And you see it's 0.382. Okay. Now, the third question says find the probability that at most 4 are men. At most 4 are men is this one, right? The probability at most 4 are men are, what that means is the probability that x is less than equal to 4 at most. The very maximum number is 4. So this is the probability that x equals 0 plus the probability that x equals 1 plus the probability x equals 2 plus the probability of x equals 3 plus the probability that x equals 4. At most 4, 0, 1, 2, 3, or 4. So if we use the formula, again, it's a lot of work. You would have to put in x equals 0, right? N equals 10, x equals 1, n equals 10, and x equals 2, n equals 10, so on. Compute each one separately and add them up. However, if you use the table, all we do is we take our calculator, and this is the non-cumulative table, which is the one you will get. We look up 0.6, which is there, right? We look up 0.6 and we add up all of the ones up to including 4. So 0, 0 plus 0.0. The first one is 0.002 plus 0.011 plus 0.042 plus 0.111. And as you can see, it's 0.166. Okay, 0.166. So back to here, we know that all of these added up, if you were to compute it by hand, it would be 0.166 or 16.6%. I'm going to show you the table that's cumulative as well. So if you look at the cumulative table, we know it's cumulative again because the last row will be 1. So x equals 0 to 10 is this 1, 0.6 is here. So the cumulative adds up everything starting at 0. So if I look up the 4, x equals 4 successes, right there, right, at 0.60, I see it's 0.166, which is the answer, because this is cumulative. It's added everything up from 0 up to and including 4. Now let's go back to Excel. We can also do this using the Excel formula, binom dot dist dot range. The range again tells you that you can put in a number from x equals to the first number to the last number. So the number of trials is 10, comma. Probability of success is 0.6, comma. The first number is 0, right? Comma, up to 4 and including 4. Close the bracket, and you see it's 0.166. And that's how you do a binomial distribution. So Excel is the easiest way for sure. Or you can look up the tables and add them up, which is the table that you will get, which is the non-cumulative. I hope that helps this week's lesson.